Hi viewers, the reason I'm standing here is because I'm waiting on our two geography students, Jason and Stephen. In our previous lesson, they were discussing the relationship between volcanoes, earthquakes and mountain ranges. So today we'll take the discussion further and they'll tell us more about mountain ranges. The objectives of this lesson are to enable learners to explain the relationship between plate movements and fold mountains, identify different types of fold mountains on sketches and photographs, indicate the global distribution of fold mountain ranges on a map. So, I see them coming. Enjoy the program.
Why are you making us come down this road? It's much further from where we're actually supposed to be.
Just hold on, we're almost there.
How much further?
Okay,
Are
here
we
we
there?
are. Here we are.
Here we are. Dude, we're in the middle of nowhere.
Jason, come on. Look in front of you. Can't you see?
See what, dude? I can't see anything.
Look at the rocks in front of us.
Okay. They're in layers, so I guess they're layers of sedimentary rock.
You're right. You know what? I think I'm going to take some pictures for our lesson.
Alright, that's cool. Let's do that. Yes, that's actually alright. But you can see here that the layers, some of them are actually slightly bent.
Jason, can you take some photos while I point at something?
Yeah, sure. Give me the camera.
Jason, do you see these rocks here? The top of the fold is called the anticline, and the bottom of the fold is called the syncline. Jason, you have to take some more photos, dude. Let me take some pictures. So, now we can use the photographs and diagrams together. Although we do not have fold mountains in our country, these photographs should explain mountain building.
What do you mean by mountain building?
Well, fold mountains are formed by the folding of sedimentary rock layers, which have been deposited over millions of years.
Okay, I have a question. But first, what are sedimentary rock layers?
Sediment is something that is deposited as residue, particles, or remains. In this case, bits of rock that collect over millions of years in the same place.
Okay, now for my question. How are these sedimentary rock layers folded?
Folding occurs when sedimentary rock layers are bent and folded under tension exerted on them.
And where does the tension come from?
When tectonic plates move together and converge, meet or collide, there is tension. For example, when two continental plates or a continental plate and an oceanic plate collide, layers of sedimentary rock are squeezed under enormous pressure. And this is when they are forced to bend upwards or to fold upwards.
Okay, now I see. This bending continues over millions of years, forcing rocks to bend upwards, and this is how it results in fold mountain ranges.
It's important to remember that the tension is caused by plate movements. So it means that fold mountains are formed along plate boundaries.
Yes, you said that they are formed at convergent boundaries, where two continental plates collide or where an oceanic plate collides with a continental plate.
Let me show you on the map. The shaded areas on the map illustrate the distribution of some major fold mountains. Where do you see them?
Some are found along destructive plate boundaries, where an oceanic plate collides with a continental plate. For example, the Andes Mountains there. They are formed where the Nazca plate collides with the South American plate.
Yes, a fold mountain which is formed along a destructive plate boundary is called a peripheral fold mountain. Periphery means edge. As you can see, the Andes Mountains lie on the edge of the continent.
Okay, but what about those that are formed at a collision plate boundary?
A collision plate boundary is where two continental plates collide. The best example is the Eurasia plate collides with the Indo-Australian plate.
Oh, I know which fold mountains are formed along that boundary. It is the Himalaya mountains.
Yes, and fold mountains that are formed when two continental plates collide are called intertectonic fold mountains. This is because they lie in the center of the continent.
Okay, let me just recap before I get confused. Fold mountains are formed along destructive and collision plate boundaries. Fold mountains that are created along destructive boundaries are called peripheral fold mountains because they lie on the edges of continents. The Andes Mountains, which lie on the edge of South America, is an example.
Correct. And fold mountains that are formed along collision boundaries are called intertectonic fold mountains because they lie in center of continents. The Himalayas are an example of these that are found in the center of Asia.
But remember, folding occurs below the crust. These folds are only slowly and gradually uncovered. They become visible only after thousands of years of erosion and weathering of the surrounding landscape.
Isn't that interesting? This means that the top parts of fold mountains are older than the lower parts.
Okay, now you've lost me. Why are the top parts of fold mountains older than the lower parts?
The top parts of fold mountains were pushed up and exposed to weathering and erosion before the lower parts. This makes them older than the lower parts. But do you know that fold mountains are still growing higher?
Yes, I read about it recently. Fold mountains increase in height by a few centimeters every year. Does that even make a difference?
Yes, it does actually. Fold mountains have been growing so fast. Or is it slow over millions of years? And just look at how high they are today. The highest peak in the Himalayas is just under 8,850 meters above sea level. How is that for growth?
Okay, so fold mountains are formed along destructive and collision plate boundaries. They are called fold mountains because sedimentary layers of rock have been folded and bent upwards to create them. This folding took place inside the crust due to tension, and the folds were exposed over millions of years by erosion. And folding still happens because plates are still moving, resulting in fold mountains continuing to grow higher.
That's a great summary, Jason. But we still have to look at the different types of folds.
Okay, I've already summarized it in another folder. Here it is. By the way, we have to mention, Stephen, that with folds we simply mean the way in which the layers of sedimentary rock are bent and are crumpled.
Okay.
So it actually gives us an idea of what a fold mountain looks like on the inside. Let's list the different types of folds.
I'll start. There are 4 types of folds, and they are monoclinal folds. Here's a photograph of it. Then there are symmetrical folds, asymmetrical overfolds, and asymmetrical overthrust folds.
You'll have to explain more on that.
Okay, sorry. A monoclinal fold occurs when the force or push occurs from one side only. Symmetrical folds occur when force is applied equally from both sides to form a fold with even sides. The top of the fold, A, is called the anticline, and the bottom, S, is the syncline. This is where we can show that other pictures of yours. Yes, that one. There are 2 kinds of symmetrical folds. Symmetrical open folds occur when the pressure was not too much and was applied from both sides to form an open fold. And symmetrical closed folds occur when a very strong force was applied equally from both sides.
And the asymmetrical overfold occurs when, although there is pressure from 2 sides, it was much stronger from the one side. Therefore, the axis or center line of the fold is no longer vertical. Here's a photograph that shows that. An asymmetrical overthrust fold occurs when the force from one side was so strong that it caused the layers to break along the fault line and to move past each other. Earthquakes originate along such a fault line. And there we have all the different types of folds.
Mr. Sienkamp and the principal will be very impressed with your work.
The principal? Why will he be there?
Well, he's visiting our geography class tomorrow.
And how do you know that?
I saw it on the timetable like 2 weeks ago.
Dude, why didn't you tell me?
I did tell you, didn't I?
Let me rather go through the work again and make sure that everything is correct. Here are the important points of today's lesson. Fold mountains are formed along destructive and collision plate boundaries. Fold mountains that are created along destructive boundaries are called peripheral fold mountains because they lie on the edges of continents. The Andes Mountains, which lie on the edge of South America, is an example. Fold mountains that are formed along collision boundaries are called intercratonic fold mountains because they lie in the center of continents. An example of this are the Himalaya Mountains, which lie in the center of Asia. In there are 4 types of folds: monoclinal folds, symmetrical folds, asymmetrical overfolds, and asymmetrical overthrust folds.
Wow, viewers, to think that fold mountains actually originated inside the Earth's crust. I hope you've enjoyed these lessons, because I surely did. There's one more geography lesson left in this series. But right now, to end our lesson, let's cross over to our SMS competition. To SMS your answer, please enter the keyword for today's competition, followed by the letter A, B, or C as your answer, to the number 5003. The keyword for this program is fold. You can see the spelling on the screen now. One SMS costs 3 Namibian dollars. Here is the question. Which type of fold occurs when force is applied equally from both sides to form a fold with even sides? Is it A, monoclinal fold, B, symmetrical fold, or C, an overthrust fold? SMS your answer to us. We will contact the lucky winner within 3 days. All correct answers will also be entered into our lucky draw at the end of the 5 programs in this series. See you next time.